My name is Karen Seto, and I am a professor of geography and urbanization science at the Yale School of the Environment. And I'm going to address this question today, and I'm really looking forward to the discussion afterwards. I'm going to address this question of urbanization. Is it a crisis or is it part of the solution for climate change? I'm going to start off with some general statistics first and put this into context. Here's where we are today, 2020. We're about here. I hope you can see my cursor. The UN estimates go out to 2050, and it is estimated that by 2050, we're going to have about 6.7 billion people living in urban areas. This is a significant change from just a century ago when we had fewer than 1 billion people living in urban areas. So one of the key points of this graph is that over the next 30 years, and certainly throughout the rest of this century, we expect a significant increase in urban population. If we look at the rate at which urban populations are growing, we see that they're growing at a faster rate than in the past. So it took all of human history to reach 1 billion urban population. That didn't happen until 1960. And then you can see from this table that between 1960 and 1986, the urban population increased by another billion. That took 26 years. And then it was only 17 years later, in 2003, that the urban population reached a 3 billion. And you can see that now we're at about a little over 4 billion. And by the middle of the century, we're going to reach 6 billion. So about every 13 years, the world's urban population is increasing by 1 billion. So every 13 years, that's quite significant. So what does this mean in terms of the landscape and the environment? We see places like this. This is Shanghai in the 1970s being transformed to this. This is Shanghai in the 2000s. So this urbanization of the planet is happening in terms of the population, but very important in terms of the environment and planetary sustainability. This has huge repercussions in terms of energy use, in terms of land, in terms of resources. 3 countries are where most of the urban population growth will take place: China, India, and Nigeria. These 3 countries will represent about 1/3 of the new urban population growth that is expected to happen over the next 30 years. So it's really these 3 countries we should keep an eye on in terms of how they urbanize and the resources that will be used. I want to just give a little more context, though, and this is important in the context of the global environment. The urban population in China is expected to peak somewhere around the first half of the 21st century. So if you look at this graph shows the total population of China, which is expected to peak somewhere at about 1.4 billion people. China's urban population here in this blue line has already exceeded its rural population. And we see that the urban population is expected to reach 1 billion by about 2030, 2035. And it's expected to level off at about 1 billion people living in urban areas. So think for a moment that all these people moving into urban areas are going to require the construction of new cities, somewhat like what I just showed with the pictures of Shanghai. So in terms of the resources required to build the cities of tomorrow, we expect that China's construction boom is really going to be completed by around 2040. India, on the other hand, India's urban population will only peak in the second half of the 21st century. And so we see here that India's total population is expected to exceed that of China's. It's expected to be nearly 1.7 billion. And we see that the urban population will exceed the rural population only around the middle of this century. So in terms of the demand for resources, whereas China will be complete with its, will finish its urban construction boom at around 2040, we expect that India will really accelerate its urban construction around the middle of the century. A couple of trends that I think are important for us to think about with regard to urbanization. We're seeing two trends that are important in the context of global urbanization. I have some data just for the US, but this reflects trends that are happening around the world. And one trend is that the average home size all around the world is increasing. So in the US in the 1970s, average single family homes were around 1,600 square feet. Now it's up to nearly 2,800 square feet. Now, I want to highlight that in many parts of the global south, especially, average home size needs to increase because average home sizes were relatively small. But for much of the global north, as in the United States, Canada, Australia, almost all of Europe, average new home sizes continue to increase from what was already a relatively large number. The other trend that's important with regard to urbanization and the environment, and especially with regard to climate change, is that while we have average home size increasing, the average household size is declining. So here are some data showing the US, New Zealand, the UK, Australia, Canada. These trends are happening this similar trend is happening all around the world, where average household size is declining. In the US, the average household size was somewhere around 3.5. We're now down to around 2.5. So total urban population is increasing, but average household size is declining, whereas our houses themselves are increasing. So all around the world, we are seeing the development of housing stock that looks remarkably like that in the United States. And if I were actually at the Gund Institute, I would ask all of you in the audience, where do you think this picture is taken? I am originally from Hong Kong, but grew up in Southern California, and this looks remarkably similar to the landscapes that I grew up in Southern California. But in fact, this is a picture of a housing estate right outside of Bangalore. And likewise, I would ask again, where do you think this picture is taken from? It again looks very much like the housing developments in the United States, but this is actually a housing development in northern China. So this style of housing of single-family detached homes is very land and energy intensive, and it is increasingly a dominant form of urban development all around the world, especially for the growing upper and middle class in the global south. So in my lab, one of my doctoral students has developed a forecast of what urban land will look like in 2050. And these results show that in the next 30 plus years, between now and 2050, we're expected to see a significant increase in urban land. So we know that the urban population is going to increase by about 2.5 billion. They're going to need land, and they're going to need buildings and houses and schools. So Dr. Huang's projection shows that urban expansion is going to result in building a city about the size of New York City every 8 days for the next 35 years. So that's the land requirements. We're going to build a city about the same size of New York, not just Manhattan, but all of New York's footprint every 8 days over the next 35 years. If we were to aggregate all this new land, it is going to be equivalent to all the area of France, all the area of Germany, Spain, and Italy combined. So that's a lot of urban land that's going to be distributed somewhere on the planet. That's just the land resources that are required. Building new cities will also require a lot of resources and significant energy. If we look at the infrastructure that will be required, the upgrading of infrastructure that will be required, we expect to see on the order of about 109 gigatons of CO2 just to upgrade existing infrastructure. That doesn't include all the new infrastructure that needs to be built for the cities that haven't been built yet. So the resource requirements to build cities will be significant. And a couple of years ago, the UN International Resource Panel developed some estimates of the resources that would be required just to build cities. And they found that under a business as usual scenario, now this business as usual scenario is given the trends that I just talked about, declining household size, increasing in household area or home size. Under these business as usual scenarios, the resources that are going to be required just to build and operate cities will more than double between 2010 and 2050. And most of this this increase in resource use will be in Africa and also in East Asia. Now, one of the questions that I'm asked quite a bit is, well, aren't cities more efficient? It depends, and I'm going to get to that in just a minute. I started off this talk by asking the question, will urbanization be a crisis or a solution? If we were to take the top 50 emitting cities, and if these top emitting 50 cities were a single country, they collectively would rank third in emissions behind China and India. Now, these data that I'm showing here are about 10 years old now. So maybe it may not be exactly the third, maybe it's the fourth, but nonetheless, the top 50 emitting cities are up there in terms of total emissions. So in terms of whether these cities could be solutions or crises, I would argue that this could be tremendous opportunity to help with solving climate change through these 50 cities. And I'm going to get to that a little bit more in just a minute. The other thing to think about is based on the work of Dr. Huang and his forecasts, we've shown that more than 65% of the urban areas that are expected to be in place in 2050 have yet to be built. So more than 65% of urban areas that we forecast to be in place in 2050 are not in place today. So this represents a significant opportunity to shape what urbanization looks like, how cities get developed in the next 30 years. This is a significant window of opportunity. Now, getting back to the question that I asked earlier, that I'm actually asked quite a bit, which is, well, aren't cities more efficient than rural areas? And I said the answer really depends. This is a graphic that's taken from the IPCC chapter that I co-led for the last IPCC report that's available online. You can download. What this graph shows is a tale of two different types of cities. On the left, these are Annex 1 countries, and on the right, these are non-Annex 1 countries. So think of this on the left as the global north and the global south. And what this shows is per capita urban energy use. And cities that are in blue here have per capita energy use that's lower than the national average, whereas cities in orange have per capita energy use that's above national averages. Now, for Annex 1 countries, we see that 2 out of 3 cities have lower per capita urban energy use than national averages. In other words, 2 out of 3 cities in the global north are more energy efficient than national averages. But we actually see the opposite in the global south. We see that, in fact, 2 out of 3 cities have above national average per capita energy use. Now, there are 3 main reasons why this is the case. In the global south, we see that it's cities that are primarily the manufacturing hubs in these countries. It's where things get produced and manufactured. And so, not surprisingly, it is in the urban areas where the economy is more industrial based and not agricultural. So the economy in global South cities is more energy intensive. The other is that in many countries in the global South, the more common dominant forms of energy use or energy sources are not fossil fuels or not electricity. We see that animal dung, we see wood fuel is more commonly used, so lower forms of energy. And so the combination of cities in the global South being manufacturing hubs, plus this is where electricity is more readily available, both lead to cities having higher per capita energy use than the national average. In the global North here, we see a very different story. In the global North, what we see in cities is that cities can take advantage of economies of scale. Cities in the global North often are more energy efficient because of the way in which the cities are designed. They can be more compact, but it's the economies of scale that's really important, as well as the fact that in many of these cities, the economy is not based on manufacturing. The economy is actually based more on services and less on manufacturing. So they're less energy intensive. Now, we know that urban form and urban density is really strongly related to transport energy use. And I show here a graph from seminal work from 1989, Newman and Kenworthy, that shows that here on the x-axis we see urban density, and on the x-axis this is energy use in the transport sector. Very clear correlation between urban density and transport related energy use. So here's the city that I'm from, Hong Kong, which is one of the densest cities in the world with very low transport energy use per capita. In contrast, we see many North American cities here: Houston, Phoenix, LA. These are cities that have lower urban densities and significantly higher transport-related energy use. So we know that urban form is a really important factor for total urban emissions, but that's only part of the story. What we found with the IPCC report is that increasing population density is necessary for reducing urban energy use, but it's not sufficient for lowering total energy use. And here I want to explain why. This is a cartoon we developed for the chapter, which shows 3 different communities with the same urban population densities, but they're laid out really different. In this community, this is hypothetical. This community is primarily single family homes. They're detached. This community have multifamily units, and they might have co-location of housing and work. So you might have a building that may be zoned as both residential and commercial. Here's another cartoon, cartoon of a neighborhood that has, again, the same population density, but represented or housed in just 2 buildings. So the transport energy would be very different with these 3 different prototypes, but the building energy use would be very different as well. These taller buildings, especially very tall buildings that require reinforced steel, that require elevators, the energy used to operate them is actually relatively high compared to shorter buildings. And the other thing to keep in mind is that this configuration has very different impacts in terms of the carbon sequestration potential of the green space all around it. So it's not as simple as simply increasing population density in order to reduce urban energy use. What we found in the literature is that it's co-location that is really key to reducing urban energy use. So here's an example, again, more cartoons from the IPCC chapter. Here's an example of 3 different landscapes. This one here on the far right has much more mixed land uses, where you have co-location of housing with commercial, or housing with jobs, maybe with schools, as opposed to this landscape, which has total separation of uses. So if we think about the characteristics of low carbon, low energy cities and urban areas, we want to move more towards this type of an urban land use configuration, highly mixed, co-located places. Another thing to consider, this is work taken from Suzuki, a report from the World Bank about transport in the global south. The land that's required for different types of cities also have a really big impact on energy. So this figure shows the amount of land that's required if we were to design cities around cars versus if we were to design cities for walking or for the bus. I mean, clearly the footprint would be very different if we built for the car versus if we built for the individual or for public transport, or in this case for motorbikes. So the design of the urban landscape is really important. A couple of other things I just want to highlight that is really essential as we think about future urban expansion, and why the location of where cities or future cities matter, and the form of future cities matter, is that urban expansion takes up land and results in the loss of vegetation, which affects the carbon sequestration potential. And what we see in many parts of the world, especially in Asia, in Europe, is that the urban land is taking place in places with very rich soils. And so this has significant impact for carbon stocks. I mentioned earlier that urbanization can be part of the solution, and one of the ways that urbanization can be part of the solution for climate change is through urban green infrastructure. I put up here in this slide just a couple of examples of how urban green infrastructure could mitigate both urban heat island, but also climate change through a reduction in the need for heating or cooling, and also, as I mentioned earlier, by increasing the green potential for carbon sequestration. In the US, we see that urban forests can reduce urban building energy use by about 7%. So trees can reduce the energy use through shading. And this can avoid emissions from power plants of up to nearly $4 billion. And so there's significant potential for urban forests to provide urban carbon storage worldwide. And there are some estimates that this potential could triple worldwide. So this is certainly part of the potential solution to climate change. Now, the IPCC has more recently recognized the potential of urban areas to be part of the climate change solution. Up until the last IPCC report that was published in 2014, the IPCC never had a standalone chapter on urban mitigation of climate change. And in fact, the way in which cities could mitigate climate change, or how urban areas could mitigate climate change, was primarily through the lens of sectors. So through the building sector, or transport, or land, or energy. It wasn't until the 5th assessment of the IPCC that there was a standalone chapter on how cities and urban areas could mitigate climate change. That report was published in 2014. Fast forward to 2016, the IPCC in 2016, in recognition of the importance of cities in potentially mitigating climate change, the IPCC adopted and agreed upon a special report on cities and climate change for the 7th assessment of the IPCC. We are currently in the 6th assessment cycle. So after this current assessment cycle is complete, for the 7th assessment cycle, the IPCC will undertake a special report. It's a special assessment just on cities and climate change. And that special assessment will focus on how cities can mitigate climate change, as well as how climate change will impact cities and urban areas worldwide. In preparation for this special report on cities and climate change, the IPCC held its first ever conference on cities and climate change in 2018. I was on the planning committee for this conference, and we had hundreds of participants from the research community as well as from the practitioner community. This is really essential to bring the practitioner community together with the research community to discuss what is the research that's necessary to develop this special report. We developed this report following the conference. We developed a report, which is a research and action plan, which is available on the web. It's available through a number of these websites, including from Future Earth, which identifies a research plan going forward on cities and climate change. There's a lot that's being done in terms of reducing carbon in cities, reducing energy use. Some of the most exciting work is on electrifying entire cities. There's a lot of work being done on district heating and cooling. A lot of research being done on reducing embodied energy in building materials. A lot of exciting work there. I was asked to just speak for 30 minutes, so I wanted to give a high-level view of how cities can be part of the solution going forward for climate change. I did want to end with a little video to put this in a longer perspective, a longer time perspective. I imagine that many of you in the Gund Institute are familiar with the term the Anthropocene, and it's been argued that we are now in the Anthropocene, in the era of the humans. I would argue that we are in the era of the city now. We are in the century of the city, that this is an era that's a special era in the Anthropocene. This video is based on research done by one of my master's students, Meredith Reba, where she collected the archaeological and political historical record of cities over the last 5,000 years. And what we see is a significant increase in the pace of urbanization. This video that was based on Meredith's research, developed by an animator, Max Galka, really highlights the pace and global reach of urbanization. And I think that it points to the need for us to rethink how we build and operate cities of today and tomorrow so that they can be part of the climate solution and not part of the climate crisis. You see here, we're now at about 900 AD. Cities are still concentrated within a relatively narrow latitudinal range, and it isn't around 1500 AD that they spread over a much larger area. And the animation, the study ends in 2000, and we see that cities are literally all over the planet. So the question I think I'm hoping that we'll discuss in the time remaining is whether urbanization is going to be a challenge and present a crisis or whether it's part of the sustainability opportunity, especially for cities that haven't been built. So thank you for your attention, and I'm really looking forward to Q&A and discussion. Thanks.
All right. So in behalf of the Gold Institute, I want to thank Dr. Karen Seto for such an amazing presentation. I want to remind all attendees to use the Q&A button at the bottom of your screen to submit your questions. So I think we already have one question. First of all, Taylor says he thanks Karen and he wants to welcome you to the Gold Institute Board of Advisors. And he's also wondering, do you think COVID-19 might slow the global move towards cities? Will they become seen as less safe place to be, or if not, with COVID-19 alone, how often will pandemic have to begin to shift urbanization trends?
Before COVID, the most common question I was asked was, aren't cities more efficient than non-cities? And now the COVID question is the most common question that I'm asked is, is this going to have a significant dent on forecasts about urbanization and whether people are going to move out of cities? And I'm saying that answering this question as I have migrated away from New Haven and I'm actually based in Vermont now. What we are seeing in the US, but around the world, the data show that people are migrating out of cities. But I suspect that this is going to be more of a seasonal or maybe circular migration. This is not a permanent migration of people leaving cities. My concern is that this is going to lead to concerns about cities being less safe, as you point out, Taylor, in your question, people being concerned that it's density alone or that we need to reduce density. I've been following the peer-reviewed literature on this, and there are conflicting results. It seems to be that if there were inequalities in the city, if the city had poor institutions and poor governance and poor availability and delivery of medical resources, medical services, that COVID has actually exacerbated existing inequalities that were in cities. I was on sabbatical in Taiwan for 4.5 months during COVID, the height of COVID. When I left Taiwan, the country had about 450 cases of COVID. I think it had 5 deaths. I was living in one of the largest cities in Asia, in Taipei. I think it's a good example where really strong leadership and strong governance and effective institutions can have a really big impact. But I do think that what will happen in the short run is people will temporarily leave cities to less dense places. And I think the real question is whether future cities will take COVID as an opportunity to design cities to be safer, both in terms of pandemics, but also think more about the governance and the institutions that are required to make cities more functional. It does seem from the literature that density alone does not lead to the spread of COVID in cities, that it has to do with the underlying institutional structure, the governance structure, that's pretty important. I imagine, one last thing about this question is, I imagine what we're going to see is that these trends, the global trend of urbanization is going to continue, but the pace will be slower. Another point that I think is important is these global statistics about urbanization. They represent very different types of urbanization. In Norway, a municipality that has 200 inhabitants is considered urban. And so the global data that the UN collects is not just for cities that look like New York or even New Haven. We're talking about urban across many, hundreds of different countries, different definitions of urban. But thank you for that question.
Awesome. We also have a question by Megan Hayden. She says, what do you see as the greatest barriers to achieving these goals for cities as a beacon of sustainability?
That that is such an important question. What is the greatest barriers? I would say there are three. One is we are creatures of what is it? We like to do what we know how to do. It's very difficult for us, creatures of habit. That's what it is. We are creatures of habit, and it's very difficult to change the way we do things. And I'm just going to give a very concrete example. If you are used to driving a car to get between point A and B, it doesn't matter. It's unlikely not going to matter so much if you now move to a place where you live close to between point A and point B. So if you are used to driving, you're just going to think about driving regardless of whether you can walk. If you grew up in Copenhagen and you're used to riding your bike, even in the rain, you're going to ride your bike even in the rain. It's very difficult to change this path dependency with how we think about cities and how we design cities. So there's this huge path dependency. Especially in the global south, many of the building designers, the engineers, the planners, the leaders in the global south are often trained in the global north in places like the UK, Canada, the US. So this path dependency and how we think and conceptualize cities continues, and there's this global spread. So I think that's a really important thing. There's this like the spread of ideas. Another big barrier, I would say, is that there's so much innovation, but these innovations, so let's say innovations in building design, innovations in district heating, innovations in low carbon cities, these innovations are often seen as not achievable because of lack of finances or human capacities. And we need to think about how we can accelerate these and have these solutions at scale rather than this is a this is one example. We need to really think about how we can scale them up. So I think those are the three main barriers: how we develop solutions at scale, getting out of our creature of habit, thinking about things done one way, and also rethinking the design of cities, and not just bringing in ideas from the global north, or really rethinking urban planning, rethinking building design.
Awesome. Maybe as a follow-up for Taylor's question, Hallie Sommer asks, she says, thanks, Karen. I was curious how public transport might change now that our concept of public space is changing with COVID-19.
Yeah. I mean, this is related to my answer to Taylor's question about urbanization trends. I guess, Haley, when I read your question, our concept, I think you're meaning the North American concept of public space, because I think our concept of public space is very much intertwined with our concept of a social contract. What do you do? What is the social contract around how you act in a public space? And what are your responsibilities? So as an example, when I was living in Taiwan this past spring, the social contract and the expectation was that everybody would wear masks and sanitize in all public places, not just in public transport, but at restaurants, in libraries, at the university. And the idea was we need to keep everybody else safe. Because multi-generational households are still quite common in Taiwan, there was a sense of responsibility that I must keep my family safe and I must keep the public safe. that there is this social contract. So the perceptions and the ideas around public space is different than I think here in the U.S. I think in the U.S. the idea around public space is more individual liberty, as opposed to you have a social contract to keep everybody safe. So I think that that is quite different. And because of these different social contracts, I think we think about public transportation really differently. So I did not once, while I was in Taiwan in 4.5 months there, worry about using public transportation, because everybody wore face masks. And before you got on the bus, before you got on the subway, there were hand sanitizers. And you knew that everybody was taking this incredibly seriously. I think in a place where there's so much variation in responses to COVID, there is uncertainty about that social contract.
Olin is asking, how can we deal with the trade-off between energy efficiency and segregation that can be caused by city segmentation?
I'm not sure what is meant by city segmentation. Is that city segregation, or Jorge, do you know?
Yeah, Olin says yes.
Okay, so there isn't necessarily a trade-off between energy and efficiency and segregation. So that would be a false dichotomy. I mean, there are many ways in which we could be energy efficient. Maybe you mean separation. I wonder if that's what she meant. There certainly are costs of separating uses and energy efficiency, especially in transport. But the transport sector has done a lot of research on how can we make transport more efficient if we have separation of uses. And that's where we would have to think about making the transport itself more energy efficient. So this is where we look towards electric vehicles, hybrid cars. There's also a lot that could be done in terms of reducing trips. So bundling your trips together, instead of taking one trip to get a gallon of milk, you can bundle your trip to get your milk and go to work and get your hair done and go to the dentist all at once. So bundling trips. There's a lot that's being done in the transport sector for places that are separated and where the uses are separated. And that's primarily, I think, one of our strategies in North America, where we have a lot of separation of uses. We have to think about making the individual buildings more efficient, as well as making the mode of transportation more efficient. But it goes back to one of the questions, or one of the points I made earlier, which is we need to break the high carbon lock-in that we have in North America and many other places. We have to change our mindset about what is normal, what is the normal in terms of how do we get between point A and point B. We are a very independent, car-centric culture. And not just a car-centric culture, but we're a individual car-centric culture. I know this quite well, having grown up in California. However, the research has shown that it doesn't take much to change this high carbon behavior if individuals are shown that you can achieve similar utility or similar levels of satisfaction, happiness, your goals, and have through low carbon alternatives, so through walking or alternative modes of transportation.
Awesome. We have another question by Luis. He says, well, first he says, thank you for your talk, Dr. Seto. I am curious about your thoughts on urbanization and planning cities in small island nations and territories in light of climate change. Are there sustainability trade-off in creating resistant or adapted cities to the impacts of natural hazards in islands?
Yeah, that's really interesting because Luis's question is specifically about planning cities in small nations or small island states, where clearly the impacts of climate change will be really significant. So some of the research is showing that the way in which cities adapt to climate change may in fact lock them into high carbon futures depending on their adaptation strategies. So just as one example is cities and especially coastal communities that that rely more on increasing the built environment, so concretizing the land area, that can, not necessarily will, but can lock in maladaptation in the future. It can also lock them into certain patterns of high carbon and high energy use. So certainly there could be a trade-off there. And again, some of this research here is showing that more nature-based solutions for adaptation may be more flexible for also achieving low carbon futures. So these nature-based solutions, especially for cities and in small island nations, would be like through wetlands, wetlands and mangroves, etc.
Awesome, thank you. We have another question by Aaron Swartz. He says, can you speak a little more about the global research agenda on cities? What are some of the high-level research gaps around cities being part of the solution for climate change?
Yeah. So I encourage, especially the students on the call, I really, really encourage you to download the report. We have a short version of the report, which is I think 5 pages, and then we have a long version, which is I think like 40 pages. I'll just highlight a couple of high-level gaps. One of the big gaps actually follows on the question about, I think it was Luis's question about adaptation and in small island states. So one of the big gaps is, how can cities adapt to climate change? And cities are really faced with two big climate threats. One is global climate change. The other, which I didn't even talk about today because I only had 30 minutes, the other is that as cities expand, they alter their regional climate. The urban heat island is well known, but one of the things that our research is showing is that it's not just the urban heat island, but also that the growth of cities can affect precipitation patterns as well. And so you have both climate change at the global level, but also urban induced regional climate impacts, both in terms of warming and more warming, especially in the evening. So nighttime warming increases, but then the other is a big impact on precipitation. So how cities will adapt to climate change is a really big gap. There's a lot of focus in the popular media and in some of the academic literature about sea level rise, but for many, many cities, the biggest threat will be heat. Sustained heat. It's not just heat for one, hot, elevated temperatures for a few days, but it's sustained elevated temperatures. And this is especially the case in especially a concern and an issue in the global south, where we're expected to see more urban development. So you think, imagine these landscapes that are currently agriculture, or maybe they're vegetated, and they become concretized. There's going to be a significant change in temperatures and in regional climate. So that's one big gap, is more on adaptation and vulnerability to climate change. The other big gap also relates back to one of the questions about mitigation and sustainability, is we have a lot of pieces. We have a lot of pieces about how to make individual buildings more energy efficient, how to make cars more energy efficient. We know that certain urban forms, certain configurations of the urban landscape lead to or result in lower carbon footprints. Why can't we do this at scale? That is one of the big questions. I am not an urban planner. I'm not trained in urban planning. I'm trained as a geographer and an urban scientist. I'm learning through working with planners that the development and building of cities is not a top-down, and maybe some of your urban planners on this call. I mean, it's not this top-down linear process. And in much of the global South, urbanization and urban development is happening through more informal pathways. So it's informal urban development. It's not formal urban development. It's not the public sector coming in and providing services like electricity and water and waste management, but it could be the private sector and again more informality. So the other big gap is how do we find solutions at scale, and then big questions around governance and the institutions to make this work. It's very clear, I just want to, one last point about this is, it's very clear from the science literature that it's possible that cities can be beacons of sustainability. It's not clear from the social science literature how we actually make that work. We have the science technology to do it. We now need the social science to figure out how do we get these different players and policymakers across different scales to actually build urban areas that are more energy efficient and lower carbon footprints.
Awesome, thank you. And I think we have time for one last question. So Robert Herendeen is asking, have you considered the beyond boundary impact, which depend on affluence, along design how much overall economic growth cancel out the efficiency increases and fuel switches you mentioned?
Mm-hmm. That there are a lot of research on urbanization's impact on energy and climate and the environment tend to confound the urban impact and the income impact. That many studies assume that urbanization lead to higher income, and this higher income lead to higher, more energy consumption, etc. The one thing that is indisputable, so we can actually hold income aside, the one thing that is indisputable that is certainly urban is the configuration of the urban space. And so this is part of the work that we did for the IPCC is when you look at the published literature, it's very clear that holding income constant, urban form, the structure of cities is one of the biggest determinants of urban energy use. So if we hold income constant and we take away the economic structure of the city, so obviously if you're a manufacturing city, you're going to have a very different carbon footprint than if you're a services city. If you're a call center versus if you make refrigerators, these two cities have very different carbon footprints. But if you take income aside and the economic structure, it is the urban form, it is the configuration of the urban space. Things like the width of sidewalks and how amenable they are to pedestrian traffic. It is the presence of street trees and urban forests. It is the configuration or the layout of streets and the buildings relative to the street design. All of that together has such a big impact on the local climate, but also on the materials that are required, as well as the energy that is required to heat and cool and simply to operate these cities. So the urban form is one of the biggest impacts. And it's, again, here I want to emphasize that it's not density alone. I mean, density is important, and it's a relatively easy metric to gather. And it's one of the reasons why we use urban density, because we can get that data for many cities around the world. But it is really this issue of urban form. It's the structure. It's where things are located relative to each other that becomes really important in terms of the entire urban energy profile.
All right, thank you so much. Well, I think that will be all for today. On behalf of the Gun Institute, I want to thank Dr. Karen Seto for giving us such an amazing presentation, and everyone who joined us online today. We also want to thank you. We will have the video and podcast of today's talk available next week. Before you leave, please join us again next Friday for our next gun exchange with Ranaibo Rasolofoson from Cornell University, whose talk Fishery and Child Development in Lake Victoria, Kenya will be on October 16th. Thank you all and see you there.
Thank you.
Thank you.